Yes, yes, please ask the students to join the class immediately. I'm starting the class here, the polarization of light. Okay. So in the earlier classes, we studied about the interference of light, and also we looked at the diffraction of light. These we have seen, okay, in the earlier classes. Now, what is the importance of polarization? You have to say it. The interference or diffraction, okay, of light, if you say it, these are the properties shown by waves. Diffraction, interference of light, okay, is the properties shown by wave nature. So wave nature only can show the interference and diffraction patterns. Therefore, the light is beyond doubt, okay, proved that it's a wave. So thereby we are seeing that light propagates, okay, or shows, we say propagates, or we say shows a wave nature, shows wave nature. But we know that shows wave nature, okay, wave nature. But we know that waves may be a transverse or maybe longitudinal. So these two, that is interference and diffraction, has shown that light is propagating in the form of waves, but they don't throw any light whether the light waves are transverse or longitudinal. So the property diffraction interference are just inferring that light is a wave, but the property polarization, if I say it, okay, polarization of light, beyond doubt, it is established the fact that the light is a transverse wave. So therefore, they found that the polarization of light, we will define what is polarization soon of light. Polarization of light, okay, proved beyond a doubt that okay, light is a transverse wave, that light is a transverse wave, transverse wave. The transverse nature, okay, is observed only when the wave shows polarization. So thereby the polarization is now the key to establish that the light is transverse wave. But light, what do you mean by light? Light is only visible? No, light is not just limited to visible spectrum, because we know that, okay, visible spectrum, if I take visible spectrum, okay, the light in which we can see with our eye, naked eye, extends from 4,000 angstroms, that is violet, to 7,000, which is red, Armstrong units. Otherwise, in other case, you can write it as 400 nanometers to 700 nanometers. This is the light in which our eye can, okay, see. But there are free light waves having a wavelengths, okay. These are the lambdas I have given it. There are the lights which are having wavelengths below 400 and much above 700. Thereby we have now, okay, uh, the waves that fit are showing transverse nature. We call them as electromagnetic spectrum. Therefore, they found that the, okay, we will say that light, a visible spectrum, is a small part, a small part it, of the large small part of large EM spectrum, large electromagnetic spectrum, electromagnetic spectrum, where all these electromagnetic waves are used for different applications. Electromagnetic spectrum. Spectrum. Then this is generally known as EM spectra or EM waves. So light, ordinary light, or we say whatever we are visible is part of EM wave. So light is EM wave. Light is okay an EM wave. Electromagnetic wave means that the light what we are looking should have electric component, or we say electric field component, and this is represented by E bar, electric bar. At the same time, this also will have magnetic component M for magnetic field component. Magnetic field component. So there are two components. But as it is a transverse wave, these electric and magnetic components are perpendicular to each other and they are perpendicular to direction of propagation also. Because we defined the transverse wave is one having vibrations perpendicular to direction of propagation. That is transverse wave one. But here in electromagnetic waves, we have two vibrating vectors. One is electric field vector and other is magnetic field component, and this magnetic field component is now okay we represent and as we write this as B bar. So we have electric vector E bar and magnetic vector B bar. Component, this is component, we call it as. So therefore, all electromagnetic waves, whether it's visible or infrared or maybe UV, whatever maybe, they are having E and B, two waves perpendicular to each other in electromagnetic waves. And the electromagnetic spectrum, if you talk about this, it's a very huge spectrum, maybe consisting of a large number of waves. Maybe we have X-rays, it may contain X-rays, or it may be gamma rays, or it may be microwaves, radar waves, microwave, or we call it as radar waves. Radars will operate in microwave region, radar waves, or there may be we have IR, infrared, or maybe UV, or maybe visible. It's a very, very big spectrum. And out of this big spectrum, you can only see a small part called visible spectrum. And it includes many other waves also called as sky waves. We have sky waves, etc. We have. Okay, so all these are the part of electromagnetic spectrum, but we will only focus on a visible spectrum where the wavelengths are from 400 angstroms to the 700 angstroms, 400 being the violet and 700 is approximately red. And now, when we have electric field component and magnetic field component, we say that in ordinary light, whatever the light you are saying, we will say that in EM waves or light waves, you can take it because all light waves are now proved as electromagnetic waves, by Maxwell. So a scientist called Maxwell As a very, very important scientist, Maxwell proved light waves, okay, proved light waves belongs to EM spectrum, belong to EM spectrum. There is electromagnetic spectra. Therefore, we say that in EM waves will have E and B which are okay at we say here we write here that I write in EM waves whatever you're taking EM waves. The important thing is EM waves which are transverse in nature. Transverse, transverse. Yeah, roll number 11. Are you online? Roll number 11. Roll number 19. 11. Chinmayi, you're online. Roll number 10. Bharat.
Sir, yes, sir.
Yeah, how do you define transverse waves? How do you define transverse waves? Govind, roll number 16. Kalyan, roll number 19.
Sir,
Yeah. What are transverse waves? Anyone in the class, can you define a transverse wave?
sir,
Yeah.
energy from
Kalyan.
one point to another point, sir.
Yeah, Kalyan. Repeat.
Displacement.
Energy from one point to another point, sir.
That is electromagnetic wave. I want the definition of transverse wave. Longitudinal wave, you know how to define longitudinal wave?
Excuse me, sir.
Yeah,
Roll
Chinmay?
number 11. Sorry, sir, there was a problem with the mic.
Okay, Chinmay, can you define transverse wave?
Sir, it moves perpendicular to the
Ah,
direction of medium.
direction of medium. That means the vibration should be perpendicular to the direction of medium. Therefore, in EM waves, what we call it as transverse waves, there are two important things you have to remember. One, the vibrations must be parallel to, okay, I say that here, the vibrations of V vector and B vector, vibrations of E vector and B vector, okay, and E bar and B bar perpendicular to direction of propagation, perpendicular to direction of propagation. So I suppose here the direction of propagation, okay, is along z-axis, direction of propagation. So I now suppose say that this is the direction of propagation I am drawing here. This is the direction of propagation. I call this is z-axis. Okay. Then I'll take two perpendicular axes y and z in such a way that suppose say I take this is now y-axis I'm taking and along x-axis suppose say I take this is the x-axis which is perpendicular to it. This is the x-axis. Now if E is along y and B should be along z because the vibrations E and B are perpendicular to direction. Both are perpendicular. Both are perpendicular means that E and B should also be perpendicular to each other. Therefore, in electromagnetic vibrations or electromagnetic waves, E and B are perpendicular direction of propagation and another important thing is E bar and B bar are perpendicular to each other. to each other. Therefore, we say that if I consider only E vectors, okay, E vector should vibrate along the direction of propagation. Suppose I say that the E vector is vibrating along the direction of propagation, okay, perpendicular to the direction of propagation. This is now I say as a E vector. Means that, okay, I suppose here that they are vibrations of the particles medium, they vibrate like this. But here there is no need of medium because you know that light rays will move, okay, by the means of fields. When field is moving, it is only energy, as Kalyan said. It is only energy movement. Therefore, for travel of energy, medium is not necessary. Hence, the okay waves which we are now talking about, electromagnetic waves, they don't need any medium to propagate because they are propagating by the concept of fields. Hence, the field concept, gravitational field, okay, electric field, magnetic field, etc. are introduced because they are transmitted in the form of energy without requirement of medium. Hence, electromagnetic waves, light waves are coming from sun to earth, even though there is no medium in the large space between earth and sun. Okay, and this is the E vector. I say E vector is now, if I say, is perpendicular to the direction of vibration, that is Z axis. Similarly, if I take B vector, okay, and B vector, if I choose it, that B vector is now along the x-axis, something like this. When it is along x-axis, okay, I take this is the x-axis like this. Okay, I'll write again. This is the one. So therefore, now the vectors, vibrating vectors are perpendicular to this and perpendicular to direction of propagation also. They are perpendicular to propagation of also. So now that means this is 90, okay, and also this is 90. This is 90. So therefore, every time as wave moves on, this wave, whatever you are taking as a B vector, it goes and moves like this and goes like this and goes like this. But at the same time, if you just find out the, okay, E, E vector goes like this, and they are always perpendicular to each other in a manner they are moving. So thereby, if I want to draw the vectors corresponding to this, okay, this vector is perpendicular to y, therefore now it is negative y-axis. They are perpendicular to they are parallel to y-axis, but negative y-axis. Therefore, they are still perpendicular to z-axis. And in case of the E vector, B vectors are again perpendicular, something like this, to the B vector, but they are again negative x-axis. So thereby, as the wave propagates along the z-axis, these vectors will rotate and move. That means they are not simply like this. They are just rotating and moving. And the next time it comes somewhere here, like this. Therefore, always the light vectors, whatever we are taking, here they are perpendicular, and the next moment, the E vectors will be something like this. Okay, these are the E vectors and goes like this. The next moment, they may be something like this. Okay. And if you talk about the B vectors, and all B vectors will be, okay, perpendicular to these vectors and also perpendicular to z axis. They are perpendicular to this. And if you go here, they are something perpendicular to this, like this. Therefore, every time the electromagnetic wave not only will have E and B perpendicular to each other, but both of them are perpendicular to the direction of propagation, because I'm taking this as direction of propagation, direction of propagation, propagation. And you also should remember that this wave as propagates in this direction, it rotates. That means initially the E vector, as you know from your basics, that as the E vector undergoes changes, a varying vector produces dash. A varying electric produces what field? Yeah, roll number 37. Can you say the varying electric field produces what?
Magnetic field.
Yes, correct. Yeah, roll number 52. Therefore, actually, if I talk about this electromagnetic wave, electric vector is changing its direction. That means at one time it is something like this, okay, perpendicular to it. Next time again it is perpendicular in this direction, but next time it is perpendicular in this direction. Next time it is perpendicular in this direction, like this. That means as E vector is being changed or undergoing variations, automatically magnetic field is produced. That's why in electromagnetic field, since E is changing, B will be there always. Therefore, B is the cause, effect is E. E will be changing, therefore B is down. And moreover, for human eye to recognize the colors or whatever the light that is coming, E vector is more important because eye is more sensitive to E vectors. Therefore, in a light, how E vector is behaving is important. That means if I just look from this axis, okay, I just look from the direct x-axis from here, I feel that yeah, E vector is initially in the upward direction, but later it has moved to, okay, a perpendicular direction, downward perpendicular to x-axis, okay, and it is perpendicular to axis line. And later it is now perpendicular in this direction and perpendicular in this direction. And if you come to this point of it, it is now in this direction. Okay, it is this direction. Therefore, if I view a light, okay, any light coming from the direction of propagation, I will have the rotation of E vector in all directions, but every time it is perpendicular to B vector and also perpendicular to the Z axis. Therefore, E vector looks like having vibrations in all directions. That means E vector, okay, having vibrations as it propagates, because E vector goes on turning, rotating. It is rotating and moving. That's why we have a B vector. So E vector having vibrations, okay, in all directions with respect to direction of propagation in all directions. I have E vector in this direction, I have E vector in this direction, and everywhere I have a E vector like this. So if you find any direction from the direction of propagation, you can find a E vector here. Therefore, we say that in a light, in a normal light, in a normal light, normal light, okay, normal light means whatever you are using, normal light, E vector okay, E vector having vibrations in all directions. Such a light having E vector in all directions is called unpolarized light. Okay, such a light having E vectors, E bar, in all directions, in all directions, any direction you can, we have a E vector directions is called unpolarized light, is called unpolarized light. This is what the light we will see in our daily life. The light coming from sun, light coming from a bulb, or light coming from a sodium vapor lamp, etc. They do have unpolarized lights. Such a light having E bar in all directions is called unpolarized light. Then what is meant by polarization? We have to say is called unpolarized light. So unpolarized light is represented by a star like represented generally in books or by represented by, okay, this is the unpolarized light having here, and is also vibrating in this direction because you can find the light vector anywhere in any direction. If I suppose say that, okay, if I take, this is the direction of propagation perpendicular to you, just like this, perpendicular to you in this direction. So you can see a star-like structure. This is star, okay, if you say it. So thereby we say that such a light is represented by like this. But however, I want in some special applications and in some cases, light will lose some of its vectors. Some of its vectors it will lose. That means I use some device here. I put a device, some device. Okay, I take here some special device. I just write a special device like this. This is a special device. This will have a different property that when a light falls on it, I'm taking a light, unpolarized light I'm taking. Okay, so I'm taking here an unpolarized light. Unpolarized light is now represented by a star like this. Is unpolarized light we call it as. This is unpolarized light. Unpolarized. So unpolarized light is a regular light what we see it. Unpolarized light when it's falling, it has to come through the device. The light transmitted light will not have all these vectors. Either it will have a vector like this or a vector perpendicular to it. A vector like this, that means some of the vectors in this direction are allowed, this direction are allowed, therefore they're coming here, or maybe a perpendicular one is coming here, and other directions this, okay, or maybe this, or maybe having some angle, they are removed by the device. Then we say that, okay, this will have the light transmitted light has only few transmitted light. If I say it, okay, this is the incident light. Incident light is unpolarized. When this is passed through a device, then the device is removing or capable of, okay, removing, suppose say, capable of removing some of the directions of E vibrations in particular, and they are allowing only a few light rays coming here. That means not few light rays, we say light rays having vibrations confined to a particular direction. So out of all this in the star, we say that this is not allowed, this is not allowed, this one, a parallel one is allowed, and this may suppose say may be allowed. That means this is coming, there are E vector vibrating like this is coming, or E vector vibrating this is coming, and rest of them are removed and they are totally abstracted by the device, and those light vectors vibrating in different direction, they are not coming. So that means here, okay, we say that The light is now having the vibrations only in specific plane, confined to specific plane. Or we say that light vector E vectors having vibrations confined to particular directions. Here we say all directions, but here we say some directions. So the light that has vibration confined to a particular direction, not in all directions, is called a polarized light. That is what we say, a polarized light. Polarized light. So we define now a polarized light, okay? A polarized light. Polarized light. A polarized light have vibrations of E vector, vibrations of E vector, E vector confined. We have to confine it by using some device. Okay. Polarized light have vibrations of E vector confined to a particular direction, a particular plane or planes, particular planes or maybe a few planes. A polarized have vibrations of E vector confined to a particular plane or directions. Okay. So such a light having vibrations, E vibrations limited to few directions, not all, okay, directions is called polarized light. Polarized light. We call it as a polarized light. This is important. But how many directions are available? Okay, or passed through or transmitted to the device. Okay, and the device which converts unpolarized light into polarized light is called a polarizer. Okay, the device, whatever we have used, device. Okay, that we also see the construction working of device. That device that converts an unpolarized light, un, unpolarized light, an unpolarized light into a polarized light. That means, okay, polarized light is called, we have a name for this called as, okay, polarizer. Is called polarizer. Polarizer. So what is a polarizer? Roll number 13. So this device is now a polarizer. Yeah, roll number 13. Roll number 20. Roll number 20.
No.
Yeah, what is a polarizer? How do you define a polarizer? Yeah, roll number 59.
Sir,
Yeah,
hello.
what is a polarizer now?
So
Yeah,
polarizer
tell
is a
me, I can
device.
hear you.
A polarizer is a
Yeah,
device which converts unpolarized light into polarized light.
good, very good. Okay. Therefore, what is a polarized light? Roll number 38? 2038. Ashwardhan, Sivardhan, 2038. Yeah, roll number 4, Ananya. Ananya, what is a polarized light? Anyone? Can you tell what is a polarized light?
Light having E vector vibrating limited few directions.
Yes, correct. Very good. Therefore, we say that, okay, the polarized light, polarized
Sir,
light
your video is lagging, sir.
acquires, yeah, tell me,
Lagging, sir.
polarized light,
Sir,
lagging.
your video.
Yeah, now if you have any lagging, that is because of slow internet connection at your place or at my place. But I am not finding any slow internet connection at my side.
Or actually, I'm also getting your screen late, sir. It is responding
Your
five
audio
seconds
is
late.
then
Yes, sir.
Yeah,
Your
yeah.
video is
Lagging
lagging,
is
but
there
your
because
audio
of
is clear.
maybe, yeah, lagging is there because of bad internet connection. Okay. So now we will look at a polarized light. A polarized light, if I take it, is one which acquires acquires the property of one-sidedness. Property of one-sidedness, one-sidedness with respect to vibrations of E vector, E bar. What do you mean by this? Don't say that a polarized light will be seen from one side only. No, it can be seen. But another important thing is that our ordinary eye cannot recognize the difference between polarized light and unpolarized light. Okay, our eye has no capability to recognize between the polarized light and unpolarized light. That is most important. Okay, and a polarized light is one which is having vibrations limited to some planes or some directions only, and okay, it acquires the property of one-sidedness. We call it as property acquiring one-sidedness. And another important thing is that normal eye, unless until you have a polarized glass with your eyes, normal eye cannot recognize, cannot distinguish, we say, distinguish between a polarized and unpolarized lights. Polarized and unpolarized lights. Unpolarized light. It cannot distinguish. Our eye has no capability of distinguish, okay, between a polarized light and unpolarized. That's why we need some devices called polarizers and analyzers to analyze whether the light is a polarized light or an unpolarized light. Yeah, can you see the screen I have shared? Is it visible now?
Yes,
Yes,
sir.
sir.
Yeah.
Yes,
So
sir.
you remember that the polarization
Yes, sir.
is not seen by or not observed by our normal eye. So therefore, what are the differences between a polarized light and unpolarized light? So now we will write differences between, okay, or we say distinguishing between difference between a polarized light and unpolarized light, polarized and unpolarized lights, unpolarized. First, I see the unpolarized light, okay, and then we go for the polarized lights, or we better make a table here to see one or two important differences between a polarized light and an unpolarized light. So I take here unpolarized light, unpolarized light, and I talk about here the polarized lights. Okay, so if I take a straight line here, I draw here a straight line, and here I take here unpolarized light, polarized light, polarized light. So first important point for unpolarized light is that, okay, it will have E vibrations or E vector vibrations, okay, vibrations are in all directions, all directions. That means we say that, but remember that E vector vibrations are parallel, perpendicular to direction of propagation Z, and also perpendicular to B, whether it is unpolarized light or polarized light, because as it is a light, whether it is polarized or unpolarized, it is a transverse wave. Therefore, E vector vibrations are in all directions. That means that may be in this direction, okay? That may be in this direction. When you look from here, that is from the point, from the perpendicular to the plane of the paper, okay? So I am writing this star in the plane of the paper, and the direction of propagation is this, which is towards you from the paper, okay? This is the one. But in case of a polarized light, if I see here, okay, the E vector vibrations, okay, always E vector vibrates. As it is vibrating, we have magnetic field. Okay, E vector vibrations are confined to few directions or only one direction. Okay. Confined to only one direction, one plane, or few directions. One plane is called plane polarized. Okay, few directions is called partially polarized. To only one plane or few directions. That means if this is the point where you're taking, the vibrations may be parallel to this, okay, or maybe somewhere like this. That's all. Okay, you don't have other. Or you can have vibrations only in this direction and other will not be there. Or vibrations only perpendicular direction, or vibrations may be in this direction. Okay, you have this or this or this or this. Okay. So, or I can have a vertically polarized light like this only, or I have few like this also. Okay. So if I have like this two or more, it is called partially polarized. Partially polarized. If I have only one, this or this or this, we call it as plain polarized lights. These are called, okay, plain polarized. Plain polarized, because the vibrations are perpendicular to or parallel to the plane of the paper, or they are confined to one plane only. We call plane. And next, second important point, I'll write it as, if you see this star, okay, it from the direction of propagation, it is symmetrically situated. Here, there is no symmetry. In this direction, I have only vibration, but in this direction, I don't have. If you see it, I have only in this direction. the symmetry for this direction is not there. If I see it, I have only one direction. This symmetry is not there. Therefore, we say the another important point for this, the second point is that, okay, the unpolarized light is having E vector, having vibrations symmetrically, okay, about this. Therefore, we say that a unpolarized light, if you take it, have symmetrical vibrations about the direction of propagation. Have
Screen is
E
always
vectors symmetrical So now I'll write as E vectors, have E vectors. If you see this one, this is star, and around it we have all directions E vectors. Therefore, we say that have E vectors symmetrical about the direction of propagation. This is the direction of propagation. This is the perpendicular to your plane of paper about the direction of propagation. But if you just go and look at the okay, this is the polarized one. Now I go for the unpolarized one. If you see, this is unpolarized. Unpolarized is the symmetrical. Two I'll write here as have E vectors, have E vectors unsymmetric. See here, is the direction of propagation. Suppose you say, I have only in one direction. Other directions, the vibrations of E are not present. Therefore, we say have E vectors unsymmetric about the direction of propagation. Direction of propagation. Okay. These are the most important points of the differences between and polarized. This is the representation we can do for the unpolarized wave, a star, and this is a polarized light having one or two. So these are them. But there are different types of polarized lights. So we look at types of polarized lights. Polarized light. So we know that now polarized light, okay, is one which is having vibrations either confined to a single plane, okay, or maybe confined to few planes or few directions, and such a wave having acquired the property of one-sidedness of vibrations of E vector, we call it as a polarized light. So there are many types. First one is unpolarized. Unpolarized light is having, okay, unpolarized light. So unpolarized light is having vibrations in all directions, something like this. This is the all E vectors will be there in all directions. The next we say partially polarized. partially polarized light will have vibrations confined to only few directions. Few directions means that this is there in this direction, this may also be there, and this may be, that's all. The other directions are not there, only few are there. Or this may be there and perpendicular may be there, okay? Or we say that we have, or this is followed and this is there, only two vectors are there, or more vectors also there. This is a partially polarized light. A partially polarized light will have vibrations in some directions. Then we have, okay, linearly polarized light. But now they are not calling it as linearly polarized, they are calling it as plane polarized light. Plane polarized light. Linear means confined to along a direction, which is basically in a plane. Therefore, we call it plane polarized light. So plane polarized light will have vibrations, okay, confined to a single plane. Vibrations of light vector, of light vector. Vibrations of light vector is nothing but E vector, okay? E vector confined to a plane, only one plane. That means we have, this is the plane polarized, which is called as vertically polarized. Vertically polarized. Or we have like this, only vector like this. This is called horizontally polarized. Horizontally polarized. So we need sometimes these light vectors for some special applications. So linearly polarized or plane polarized. And fourth one is circularly polarized. Circularly polarized. So circularly polarized light is nothing but it is a combination of two perpendicular plane polarized lights. Plane polarized lights of equal amplitude. Equal amplitude. That means if I say amplitudes, okay, a circularly polarized light is, now suppose it is one plane polarized light and same distance along x-axis, so y-axis, and same length will be there also like this. Then we know that they rotate. When they rotate, after some time, they may be coming like this, but still they are perpendicular to each other. And after some time, they may be coming in this direction as they are changing. If you look at this as they are rotating, okay, so they always sweep a equal radii when they are moving. Therefore, if I say that, if I take now, I just suppose that these two, whatever I am taking here, okay, these are perpendicular to each other. So if I take, they rotate each other. They are rotating. Therefore, when it rotates, I suppose that the light wave goes exactly like a circle and moves exactly and goes like this. But this distance from the center, light will have same component, and that's why I will represent it. Okay, this is the way. Okay, one perpendicular one, and the other will also have same amplitude. So this is one perpendicular wave that is going like this. Other will also have the same something like this. This is their one. This is their one. This is their one. Okay, other one. So this is called circularly polarized light. And I do have another one which is okay called as the fifth point is elliptically polarized light. So elliptically polarized light, if I take, okay, this is circularly polarized light. Elliptically polarized light is again combination of two perpendicular plane polarized lights of amplitudes, unequal amplitudes, meaning that one is larger, okay, than the other. Therefore, if I want to draw this, here I take, this is the vector which I am taking in one direction, and I take another wave in perpendicular direction. This is the perpendicular direction, but it has larger component. In that case, the rotation, if I rotate this and move, okay, then the wave will be something like, okay, this. Then, if I look at this from the center, if you see it from the center, okay, I have to draw it with scale, but this is properly not drawn. This distance, okay, is different from this distance. This is having this amplitude, but this is having this amplitude. Here, this is having this amplitude, perpendicularly having this amplitude, or this is having this is having this amplitude. Perpendicular directions, amplitudes are different. And such a light we call it as a elliptically polarized light. Therefore, we have unpolarized light, partially polarized light, linearly polarized light, circularly polarized light, and elliptically polarized light. And the devices that are used to convert unpolarized light by removing some of the vibrating vectors, and the transmitted light contains only few directions of vibrations of light vector, it is called a device, namely a polarizer. And you have to see whether the given light, which cannot be distinguished as a polarized or unpolarized by your eye, you have to analyze it. And you have to tell whether the incoming beam light is unpolarized, plane polarized, circularly polarized, or elliptically polarized. This elliptically polarized light. So therefore, we need an analyzer. To know this, how to get a polarized light and unpolarized light, we have to see it. So in the next class, we will look at two important theorems, namely Malus law and Brewster's law. And also we look at different kinds of crystals, which and different types of methods of production of polarized lights. These are in this class we could able to cover only different types and definitions and distinguish between the polarized and unpolarized lights. We could not able to move further, but in the next class we'll see more about this. Okay. Yeah. Yeah, roll number 5, Arvind Kumar. Are you online?
Yes, sir.
Yeah, can you tell me what we have learned today?
Sir,
Yeah.
of light, polarization,
Uh,
polarization of light have
uh,
unpolarized light,
mm,
partially polarized light,
uh,
linear polarized, circular
Hmm.
polarized.
Okay, different types. Yeah, rule number 25. Can you further elaborate? Rule number 25. Sayarsha. Sai Harshit. Yeah, roll number 32, Rashekar.
Sir,
Can you elaborate quickly about today's class? Thirty-three, Rishikumar. No, not there. Shivanarayana, 43.
Yes, sir.
Yeah, 43. Can you tell what you have learned today?
Difference
How are
between
you?
polarized and unpolarized,
Ah,
types of polarized light,
ah,
diffraction of light wave and wave of nature
ah.
in electromagnetic and M waves of transfer waves.
Hmm.
Yes, sir. That's it. Visible spectrum.
There?
Visible spectrum, sir.
Visible spectrum we have seen. Okay. Good. Okay. Yeah. Sonia?
Yes, sir.
Yeah. What is the difference between polarized and unpolarized lights? The last question. We stop here.
E vector vibrations are in all directions in polarized light.
Good.
And in polarized vector, E vector vibrations are confined to only one plane or few directions.
Right. Good.
And
Okay.
some
Just
are
go through
in
this. Yeah. Yeah. Tell. Continue, Sonia.
unpolarized light, some E vectors will be symmetrical about the direction of propagation, and in polarized
Uh-huh.
one, E vectors will be in unsymmetric direction.
Okay. Good. Next. See, you can see these students have not submitted your assignments. Okay. Pratik Kumar, Abhishek, roll number 1, Shashant, Akshit, Fani Kumar, Siddhant,
Sir, I
Shravanti,
submitted, sir.
Siddhant,
Sir, Funny Kumar is submitted, sir. Once you can see.
but again you submit it. I am unable to see. Huh? Did you
Yes,
submit Fani Kumar to WhatsApp or to my MS Teams?
in Teams, sir.
Again submit it. Huh? Shravanti, you have not done. Prasanna, Nishant, Sandeep, Sai Nikita, Sujata 42, 52, and Sai Sumit. You have not submitted so far the assignment. By 2 o'clock today, you have to submit these assignments, these students. The rest of them have submitted. Okay, you can see your names on the screen. Are you able to see? So these are the students who have not turned in. Okay, so anyway, I stop the class here.